everybody, it is time to work on the project. So let's get some notes going here. Time for the project. I don't think we have any audio going in the background. Good. Look over here. Good. Hold this going. Let's do it. Project time. Okay, so getting started on the project. How to get started? Let's talk about this. Okay, so if you look right here, we're going to put the note in the chat. Getting started on the project. So very important right here. Make sure you read over the start of this on what you need to submit. Also, submitting by Friday will get you bonus right here. So Friday the 21st at 11:59 p.m. Get that bonus, get those 8 points. But don't turn in early if you haven't done it. I just didn't turn in early to get the bonus. And they were like, well, I wanted to turn in early to get the bonus. I was like, but you did like half the project. They're like, but the bonus, it's only 8 points. I mean, it's good, but don't turn it in early if you haven't done the project. Make sure you turn in your Excel file with your random sample and all visuals you've created for the project. We will choose and download the original data file below. Analyze your sample according to instructions. Submit it. Your Word document, including your report with required visualization screenshots from Excel. So you need to put them into your Word document. You have some creative liberties on the writing, but make sure you are consistent and the format is easy to read. Be aware of the context of the variables, output and conclusions. Put your name first, all this good stuff at the top. Section instructor, all this stuff at the top. And you can see we already have a document. Where's our document? With that information here at the top. I think this is everything we need right here. We're going to save this file again, but this is just a fake file right here and random project. Okay, here we go. And there we go. So there's our file with our name at the top, our email, fake email, of course. And then we have Smokey right there, professor, all this stuff that we can identify who you are in case things get lost or we need to identify. So there we are with the information. Please upload both of these. Whatever's the most recent submission is what will be in the grade submitter. All this stuff right here. Make sure to upload all of that. So this is what will go at the top. We've done that. Learning goals, all this stuff, scenario. Here we are. So getting started, files to submit. Okay. So this next part here is the data sets. Let's talk over getting started on the project. The data. And so there are 5 different data sets right here, each one with the Excel data file and also a kind of data dictionary for you so you can know what the files are or what the variables are. If you go to the student one, don't just do the student because I clicked on it, but you can see the names of the variables and all this. Everyone's gonna be like, I'm gonna do the student data now. But you go to the diabetes data set, Wilford Brimley with diabetes. And so you can see right here what it looks like. And there you go. There's the different variables in here, BMI, pregnancy, all these different things, different variables. And of course, download the data, the donor data set, whether or not people donated to an organization. And you can see a little short description up here at the start telling you what the data set is about. That's going to be important context for when you are writing up your assignment. So I would make sure to know what your data is and then download your data. So whenever you're getting this data right here, let's do data and random sample. You're going to take a random sample of 500. You will simply download the Excel file, whichever one you want, open it up in Excel. I'm going to open up a different file because remember, I'm not always doing the same work as you. But you'll have a data set that looks kind of like this right here. This one already has a random number on it. We're going to start editing it. I don't think you have the bike data set anymore, so I'm going to work with the bike data. 2 seconds while I open the bike data right here. And here's the original data sheet. Okay. So I have the bike data open, and let's say you don't have a random number right here. Well, if you want to take a random sample, you can simply go right here and type random number. There you go. Now you have you could have done without this, but it's nice to keep things organized. You can type equals, I'll zoom in so you can see it a little bit better. Well, I will type equals rand. So equals rand. And then we do this, and then we close it like that. And this is going to put a random number there. We're going to click this and double click the edge of this box. That carries it down. Now we're going to hit Control C and then Control V. Control C, Control V. And you notice we get this copy right here and paste values. That makes it static values. It might change them again, but these are now static values. I'll repeat this process one more time for you to see. The first thing we do right here is type equals and then rand for random number. Close off within parentheses. Now click on it and click the bottom edge right here twice. Now hit Control C or Command C on a Mac, hit Control V. With the paste option down here at the bottom, paste values. You can also right click to paste, copy, paste, but make sure you paste values. It becomes static numbers then. Truthfully, if you sort it and they rechange, as long as you're randomizing this, you're good. Now we can randomize it. To randomize the data, click the top column. And then under the home page, go to, I lost it, actually under data. Under data, go to sort, and I like to click this one right here and click expand selection. That was that button there under data. Now you've sorted them. Doesn't matter if you do it ascending or descending order because they are randomized now. We have a random sort of our data. You are asked to take 500 plus the last two of your UTID. So that means if you are using 500 plus the last two, let's say your UTID is 85. So you take 585. So just add whatever 500 plus the last two of your UTID, and that's your sample size. But you need to go one more row down. So when you do this right here, you want to add +1 to it because this is not your UTID 85. If that's your UTID, this is one row extra because we're not using the column head right there. So this means you go down to 586 after you've randomized, and you go to 586, and this is where, because we're 585, that's your data set. Hey, yo, oh, I'm sorry to hear this. Hope you're doing good, Randomize. Some points in the chat for you right there. Randomize, sorry to hear that. So you want to take 586 rows. Hope it was planned and it went well, Randomize. It sounds like you're doing well. So glad to see you here. So we have now selected those rows. We're going to delete them. Thank you, Rand. Glad. Yeah, you're welcome. And we're deleting. So there it is. Notice how you're just deleting all rows below. This is now, I would save this as, I'm going to save this as Brian's fake data for the project. You're using a different data set. But let's say my project data. Okay, so look at this. We got my project data here. Just go to File, Save As up here in the corner. File, Save As your project data, and you've got your random data now. It's been randomized. You've got 586 rows, and we've actually just completed, I think, this first task right here. We'll see if you're taking a random sample throughout this, but it's technically task 2, but we can't do the executive summary yet. So that does it right there, taking a random, it's task 0, take a random sample. So there it is, 500 plus the last two of your UTID. You won't be taking a screenshot of this. We'll be able to tell while we're looking at your assignment. It's a good idea to first do the technical tasks 2 through 6 before doing the executive summary. So let's just briefly mention the executive summary and how Brian would get it done. Okay, 923 executive summary. Work on at the end. So what I would do is if I was you and I was trying to write my report, I would use MuBot, the AI tutor we have. I'm going to pull up MuBot right here. So we're bringing up MuBot. I wonder how many usages he has now. Bringing up the MuBot. Okay. So MuBot. There's MuBot. And so can I upload my project and you'll help me write an executive summary based on what it says. So, yeah, project coach. Wait, look, mode project coach. I made different modes for MuBot. Just upload it and walk through, and he'll help with the executive summary. Let's see here. I can only read the parts you share and help you clean up. Clean professional summary that fits your, yeah. He won't do new analysis, yeah. Let me see. Someone said MuBot really helped them. I'm having a rough day. Let's see what he's. Someone said that MuBot was really kind to them. What'd you be like? That's crazy. Thank you, MuBot. He's like, we don't gotta do stats. Anyways, but looks like, yeah. MuBot is my favorite AI. He's all, and he's in the chat too. He's everywhere. If you want to shift gear, get some small done. I can help you with that as well. What do you help? You help with stats, MuBot. It's based on Friendly Neighborhood Spider-Man. So I call him Friendly Neighborhood MuBot. So I said, like, you're the Friendly Neighborhood MuBot. Everything is, if you ever feel like there's a comic book reference, That's what's going on in my class. So anyways, what I would do is randomize the seeing in the chat is I'd write your full report, and Mubot could probably help you through the executive summary. He might write, who knows. You know, you could use other AIs too. And we're gonna take a quick view to see how many times Mubot has been used, because I do like seeing how many times Mubot. He was over 1,000 a while ago. He's still at over 1,000. Okay. So executive summary, work on at the end. Do not do the executive summary now. If you're doing it now, you don't even know what to write. You don't even know what to write. So let's go ahead and do the Z, one sample Z, worth 20 points. We can do this portion right here. So this is our task 2. One sample Z. So with this one sample C, if you guys talk in the chat, we are going to build first a bar chart. Let's talk about how to build a bar chart. Once again, remember, I'm working with different data than you're working with. This is my project data. To build a bar chart, we need a variable with at least 3 levels on it. And I'm wondering when people rent bikes on Friday. So let's look what the question says again. I think it says to choose something. It says pick a category of variables with at most 3 levels. Oh, I thought. Oh, okay, good. So correction, if I told you differently, don't worry, because I was talking to someone who I'm helping through the project. Are we, Javante, did you get that part? We've randomized every row, and we should have our random sample. How you doing, Javante? So you pick a categorical variable with at most 3 levels. At most 3 levels. Brian can't read when he has to view things. I can't read. At most 3 levels. And don't worry if I worked with you on one. At most 3 levels. And then we're going to analyze it. So I'm going to pick whether or not it was raining. Identify. There's not a hotkey. Let me know if you're stuck on anything. Identify which level, nice, you consider a success and why your company is interested in this level. Once again, I'm working with data you can't work with. I'm interested in rain because those are days where our company probably loses profit. So I want to know what % of the days it's raining. Not that I think success is raining, but I'm very interested in when it's raining. So my company, because of loss of profit, is interested in rain. And don't just say because of loss of profit, we're interested in this. Come up with your own thing. Remember, I'm working with bike data. So we're looking at how often people rent bikes. And I want to know when it's raining because I think we rent less bikes the days it's raining. So we're going to go over here and we're going to analyze that variable. Create a bar chart of the variable you choose. Make sure the bars have the data labels. The information is included. Include a screenshot with what the bar chart shows. So to make a bar chart, first thing I'm doing is selecting column G. With column G selected, I'm going to insert, pivot table, insert, pivot table. And we are going to click OK to go to a new data sheet. Under the new data sheet right here, we are going to go and drop weather into rows and weather into column and values, excuse me. And if you get this blank, which sometimes occurs, go here and remove the blank. I'm glad I got that so people can see how to remove it. You just click under the filter and remove it. Now with this removed, you're going to go to Pivot Table Analyze and Pivot Chart. And probably you just want this one right here. We can make some improvements to it, but here's our pivot chart. Click under Design with the chart clicked. Under Design, pick something that looks nice. I usually go to this one under the Quick Layout. It has a lot of what we need. That's Quick Layout under Design, and then click here. Now we're going to go to Add Chart Elements and go to Axis Titles, Primary Horizontal. And I mean, you can spruce it up some more, but that's got the stuff we need. It's got a count. You can put the counts over or under. It's got titles. We need to put titles on here. Like, what are we talking about? Well, I don't want to type too much. Everyone types exactly what I type. I think this is the weather, the frequency of rain, not rain, things like that. The count of how often it rains or doesn't rain. The bar chart of rain, no rain. This is the frequency or count of observations or number of days that it, number of days. There's a lot of ways to phrase it. This is the axis title of did it rain or something like that. I met the guy who did met a voice actor. Is there a way to randomize the values all at once? Check out, we could go back to Javante here in a second, but do you have your random sample, Javante, yes or no? Do you have your random sample? I covered, and let me know if you're stuck, we covered how to get a random sample right here about, it would be 13 minutes ago. So let me know if you're stuck. We could go back to it. I'm going to save the things in the video right there, but that is how to randomize and get a random sample right there. Yes! So do you have your bar chart? Do you have your bar chart? Because this is the bar chart right here, and then we just have to fill out the information on it. So we should have the bar chart with the information filled out. Should be nice and pretty right here. Good deal. Let me know if you're stuck on anything. That's our bar chart. Good and filled out. So we've done this. Next, create a confidence interval. Now here's what I would do. What we have right here in the previous data analytics assignment is, if you take a look right here, a confidence interval worksheet. And I bet you that if we go, if we go and go copy, and then if we go over here to like another thing, like let's say you're actually in another file, look at that. So this is random ID. Make that bigger. This is categorical variable. And this is quantitative variable. Remember all that work we did for the last data analytics? Well, now we can use it to our advantage. Just want to make sure you know what I did right here. Let me say easy way to make confidence intervals. Task 2, easy confidence intervals. So what I did is I went to the old assignment. We already have this assignment done, right? So in the old assignment, I took this work right here from the old assignment. This is just data analytics 7, I believe, and went Control A, copy it all, Control C to copy, went over to a new sheet over here and pasted it in. So very important, you see those steps. So I have this new sheet over here. And what we should be able to do now is we can just enter in a lot of the values. So once again, I'm working over here on my project data, and I want to analyze the weather. So I'm just taking the weather and copying it into the categorical data. That's where this goes. This one's the categorical right here. This is cat, and this one was quant. So we're going to go right here and paste. Well, we lost it. We're going to go here, copy, paste. So now you have to be careful, though. Let's look at how these formulas are set up. So notice it says count if yes. Well, there's a few problems with this formula. We don't want count if yes. We want count if rain. Also, we need to remember how much our sample size is. I think our sample size is like 509 or 510. Let's take a look. Be careful here. We are going all the way through 586. I forgot my sample size. There's 585 sample size. So this needs to be 586. Yours needs to be how long your data is. Make sure you're doing how long your data is. And then also we need to divide by 586. Or we could also put the number in, so that works too. Yeah, it was correct as long as you go G4. And then this needs to be 585. There we go. So notice you could have put it in there as 585 because that's our sample size, because the first thing is not being used, 2 through 586. And so there's 26% days of rain. The standard error we need to put in the confidence level. I think we need to put in something like, I'm going to put in 90, but I want people to notice that your assignment says not to use 90. I want to point this out. So if you're doing everything I'm doing, we got to put the message here. Don't do the work Brian is doing. But it says not to use exactly 90. So I'm doing this because you can't. And if you do what I do, you're going to lose points. So I'm doing similar work, but not exactly your work once again. I'm showing you how to make the confidence rolls. And I think we're almost there with it because there's the interval. Done. Once again, you want to copy the data into here. And once you've copied the data, you want to make sure you've written this properly. This is the important part that does the count and finds the proportion and solves the equations. So you have to make sure this has the correct variable, has the right vector of information to go through, and has that you're dividing by the right number, which you can just put the number 585. Make sure your sample size is there. Confidence level, once again, will change the z-score. If you do 95% confidence, you'll get 1.96 or 1.599596. There it is. So make sure to put in the right values. You can't use 95 either. So once again, don't do exactly what I'm doing. And then I would change this down here. Actually, you could make this reactive because we could put right here equals this cell times 100 we go, 95. And then we could put a percent right here. Now look at that. Now it's reactive. Now you change this to like 90% and it changes even better. So yours won't change. Make sure you're putting in the right values. You can just change it yourself or do the active thing like I did. So you can actually have a calculator here. And yeah, you can probably make it even better so to calculate everything. But you want there to be a little bit of work so you know what you're doing. You know how to work Excel a little bit and make some changes. But think about this. Here's the interval and the interpretation. I am 90% confident the true proportion of days that there is rain is contained in the interval 0.23, 0.16 or 0.2316 to 0.2914. I'm just reading this interval right here. And we do want to screenshot these things. You do want to start putting these in your Word documents. You do want to put them in your Word documents. Nice, good screenshots. There we go. Picture format. There's our confidence interval output. And we also want to get that. This right here. Now, of course, this is not completely filled out. Make sure yours is filled out. I just don't want to put everything. If you do want to increase font size, you can click a font and make bigger. You can make stuff bigger. I don't like those things there. I try to get rid of them. And where's it go? I think those are our first two screenshots. There we go. Look at that. So beautiful. And yeah, there's our confidence interval, and there is our bar chart, but make sure to fill out the bar chart. Once again, I'm not doing everything. Name the three conditions. Let's call this task 2, 3 conditions. Okay, so what are the three conditions? Condition 1 is random. You have to randomly select your data, and you bet we randomly selected that data. So we've randomly selected our data. And then task 2 is going to be 10%. And I'm using samples of days of bike rentals, so I think it's less than 10% of all days bikes have been rented. Just, think about what the size of the population is. If you sampled less than 10% of the population, and if you've met the 10% condition that says you need to sample less than 10% of the population. Condition 3, you pause before saying, pause is not a condition, but condition 3 is going to be success failure. Success failure, which says we need at least 10 successes, at least 10 failures. That's the condition that says for categorical data, at least 10 successes, at least 10 failures. And with that, I think we have it. Because the amount of successes right here are that there was a total of 432 days it rained, and 153 it did not rain. And if you have other, like two groups, just do 432 minus out of the total. And that's at least 10 successes, at least 10 successes, at least 10 failures, because success was a rainy day. So I have at least 10 successes, at least 10 failures. We pass all the conditions. Interpret for the reader the confidence interval for only the chosen success. So we did that right there. I am 95% confident that the true proportion of days that it rains is contained in the interval, lower to upper, given. Oh, well, that was easy. That only took like a minute. Let's talk about task 2, hypothesis testing. Okay, we'll go a little longer on this one. So next, use 0.5 as a hypothesized value. We'll do this. Take a screenshot of here. Okay. Your company believes to be the true proportion. So it says not to use statistical notation later, but here's what statistical notation would look like. The null hypothesis would be that the true proportion of days that it rains is 50%. The alternative hypothesis would be that the true proportion of days that it rains is not 50%. So that's what the null and alternative would be. Your company believes, 50% success, or they're looking for the alternative 50% is not success. Finally, using the confidence interval, clearly explain to the reader the point of a does not equals test. So when we think about what a does not equals test is, it's this sign. There's the less than test, the greater than test, the does not equals test. So the does not equals is testing. When you think about it, It could be greater than 50. It could be less than 50. It's seeing if it's not equal to 50, where the other ones give directionality, like is it more than 50, is it less than 50, are done with a greater than or less than test, respectively. And then when we do this, finally using your confidence interval, decide whether to reject or fail to reject. So I'm not going to tell you the results of mine, but I want you to think this over. If I told you that half of UT was from New York, I believe that. That's my null. So my null hypothesis is half of UT is from New York. So I'm like, my null is that the true proportion of UT students from New York is equal to 50%. You are trying to convince me of an alternative that the true proportion of UT students from New York is not equal to 50%. And this is the hypothesized value right here. P naught goes right here. That's where P naught goes. It's always the hypothesized value on the right side. So the truth is equal to what we hypothesize is true. Now I make an interval, and the interval says somewhere between 4% through 10% of students are from New York. Now when you think about this, would you reject 50%? I would, because 50% is not in the interval. So the interval gives plausible values of truth. The interval just tells us what is plausibly true. So if the value is contained in the interval, you can't reject it. But this value is not in the interval. It's above the interval, so we can reject it because there's reason to believe that 50% is not true because 50% is not contained in the interval, so we think we reject 50%. So you reject the null when the null is not contained in the interval. You fail to reject the null when it's in the interval. Like imagine someone said to you, do you believe 7% of UT students are from New York? Well, the null hypothesis would be, this would change what P naught is. So P naught right now would be 0.07 is P naught. And then you just plug 0.07 here. And here I got that little mark on screen. Boop. 0.07 and 0.07. And then this instance, you would fail to reject the null because 0.07, funnily enough, is the center of this interval. It's like the most likely value. So you'd say, well, I believe 7% of UT is from New York. I ran a confidence roll and it had 7% contained in it, so I can't reject it. So that's how we reject or fail to reject a value, whether or not it's in the interval. A confidence interval just gives plausible values of the truth. And if that value is in the interval, we believe that it's plausible, as in like, maybe that's true. And this is why I don't say the word accept. I hate the word accept because we don't accept 7% as true. We don't accept 6% as true. We just can't reject them. Because imagine someone were to test, this is why I really hate the word reject. If someone were to test 5%, you would not reject 5% because it's in the interval. If someone tests 7%, you don't reject 7%. If someone gives you 4%, you don't reject it because it's in the interval. If someone does 5.2%, you don't reject it because it's in the interval. So any value contained in the interval is when you do not reject. It's like, well, that's believable. That's what do not reject means. You don't accept the values, you don't reject the values. It's kind of like, it's fail to reject is what we say. I fail to reject those. Well, I think that does it for task 2. That's 20 points of the assignment done. And yeah, task 3. Let's do task 3 right here. Okay. Task 3, 1 sample T. Okay, 1 sample T. What is a 1 sample T? We have a saying in our class, Mr. T is mean. You're doing drugs. Mr. T. Mr. T, drug PSA. Classic. Oh, it's on Facebook? We don't know about Facebook.
I get angry just thinking about it makes me mad. Little kids doing drugs, it turns my stomach.
Oh, man. So that's if you're doing drugs. Mr. T is mean if you're doing drugs. Otherwise, he's a super nice guy and awesome, Mr. T. So why do we keep saying Mr. T is mean? Is because the T distribution is used for quantitative data, which is means. So anytime you hear T, think we're dealing with quantitative data. It's a trick right there to help you remember it. When we're dealing with the mean, we deal with Mr. T, because if you're doing drugs, you get it. So now that we've got that memorized a little bit better, pick a quantitative variable, dealing with the mean, to analyze using statistic toolpack provided. Its descriptive statistics include a screenshot of these statistics. Okay, so let's go ahead and do the descriptive statistics part of it. Descriptive statistics here. And what I've done, if you are watching this in parts, is I've gone over here to the assignment we had. We went all the way back to our data analytics assignment, data analytics 7. We took and copied over to a new data sheet, this sheet. You can remove out what's in here and just relabel it. We don't really need the random ID, but we are going to use the quantitative vector here for later on. It'll make life easier. You can see right here, we can use some of these things down here for confidence intervals. Frankly, we don't probably need it for this one, but make the output look a little bit nice. Let's go right here. I think we paste in right there. That's where we paste. So let's have our data. I'm going to go back to my project data. And here we are with the project data. Once again, that was data analytics 7. I'm just copying over this sheet. I don't think we need it, though. Let's just do it without it. Here we go. Let's do it. Okay. I am going to analyze the average temperature right here in Fahrenheit, which means I need to go to data and data analysis. Under data analysis, we are going to go to descriptive statistics, and I have the column clicked. I need to go back and click the column again. So we're just going to click right there, and we've got the column selected. Please note that the label is in the first row. We're going to go to a new worksheet. I always like doing the new worksheet when we do this. And we're going to go to summary statistics and confidence interval and change it to something else. Once again, please remember, I am not doing the exact same work as you. So please pick something other than 90, 95, or 99 because you need to pick an interval that is allowed. That way you're doing something different. Once again, I'm picking 90. Don't pick 90 because I'm doing what you can't do. Okay, let's go ahead and click OK. And there's our work. I think if you go to table, right? Table. Yeah, look at that. Look, it's nicer. Nice and neat. You might go and take a lot of these. You know what? Everything I think can be rounded. I'm not going to round the margin of error, though. Look at your numbers and your values. And think about how they could be round. Like some could just be, like somebody once told me, the world is kind of roamy. You get it. So it's rounded up nice and neat now. Confidence, you might round this to, that's good enough right there. Because that's like a plus or minus on the interval, so we're going to keep that. Okay. We have a lot of the work now done. We do need to make a histogram, though. So let's go ahead and make a histogram. We can take our own picture of it. Here's how to make the histogram. Well, that was descriptive statistics and histogram. Histogram. Now, it's actually going to be a symmetric histogram. I kind of saw that, and I'll explain why in a moment. Insert histogram. Histogram right there. Where'd it go? Where'd it go? That's not our histogram. Oh, it's up here? What? Whoa! Wow.
It doesn't matter.
Histogram. It's a very uniform, in many ways, histogram. Very uniform. And we're going to do a little editing to this right here. Make it look more pretty. Okay, so to edit your histogram, get it centered up on the screen. Nice and good for you. And then click on it. And then chart element or quick layout, I was like, we're going to go with that one. Axis title. Axis title. You don't technically need the horizontal. I mean, it's pretty good to go if you... I'd include the height, the count of days is what would go around, because this is daily data. So this would be count of days. Like it's, yeah. So make sure to do that one, be count of days. So our histogram, make sure to call it something, histogram of temperature in Fahrenheit. Does that make sense? I'm not filling it out, so you can fill yours out, but histogram of temperature in Fahrenheit. And that's our histogram right there. There we go. Let's bring it over to our sheet. Where'd our sheet go? Here it is. And there it is. There's our picture right there. Make sure to be interpreting and explaining these things. That's what you want to do. There's our descriptive statistics. We are going to add in one more descriptive statistic over here. I'm going to go here and put in Q1 and Q3 and IQR in case we need them. To get Q1 and Q3, we're going to have to go to equals and quartile. And then we're going to have to take the array of data. And we have to go to the... Where'd it go? Oh, it's here. Good. Original data sheet. And we are taking the average temperature in Fahrenheit. So we have to take this array of data right here. And there's the original data sheet, I know. And then we're going to take Q1, first quartile, and close that. And then once again, I'll show the steps. I could just copy that code almost. But go to your original data, type equals, go to the original data, drag down, because you're still writing the function right here. Drag down on this, or... what have we done? We can actually cheat. We need to change this to N2 through 586 or so. And then notice we have a problem right here. This should be, oh, we totally made a mistake. We want quartile equals, and then we have to go to the original data sheet. And this is where we go back to the top, average temp, hold shift. Oh my word. Hold shift now. And with holding shift, click, and then click comma and do 3. And it got mad. What did it get mad about? What did we do? Oh, there's no comma. What have we done? How'd I do it and then not do it? Oh, there's a comma right here. Oh, wait, there is a comma. I'm going to just copy what we did because I got it to work. I think there's an extra equals, or does it need that equals? There it is. Look at that. Yeah, I don't know how that extra equals got there. So once again, I'll show the process again. We're going to do it right. Did it right the first time. Couldn't do it the second time. Equals. QUA. Quartile. Start the function. Go to your original data. Then, with original data selected, click on the top row. Scroll down. Now, hold shift and click the bottom row. Now, click inside the function, type comma, 3, close it with a parentheses, and click done. You did it! So now we need to find the IQR. The IQR is the range of the middle 50% from Q1 to Q3. It's like 22.77, I think. So we do equals Q3 minus Q1. Oh, I was off. I can't math it. I think there's decimal differences that are not showing up. Really? Am I going crazy? No, that's right. Brian can't math. I was subtracting oddly. Brian can't math. You can double check your work by just doing Q3 minus Q1. There you go. Brian can't math. So now we've got our IQR. We have everything we really want for this. And let's do some analysis. Okay. Provide a short write-up. So let's say writing up the descriptive statistics. 4 to 3, 13, task 3. Writing up descriptive statistics. So when we write up the descriptive statistics, you don't want to just say the mean is this, the standard deviation is this, the median is this, the IQR is this. No. You want to talk about it, interpret it, and bring context. And it says the appropriate center, the appropriate spread, which is based on the shape. So when you talk about the shape of data, this becomes a review question right here. There's really kind of two global ideas for shape. There's the idea of data that's more normal, sometimes it can be more uniform, and then there's data that's kind of skewed or data that has big outliers. So over here on this side, on the right side, let's do the center would be the median because it's not impacted by outliers. Over here would be the mean because due to the symmetry, mean and median are basically the same. Now when you do spread, the spread of data over here, I think I'm too far low, the spread of data, yep. The spread of data on the left side is going to be the standard deviation, which is usually that far apart. It can be for symmetric or for data that's not heavily skewed like this. You can use it if it looks one of those. But over here, it's going to be the IQR. So the IQR is the range of the middle 50%, which gives us about where 50% of the data is contained, and it would not be impacted by outliers or heavy skew. So important to know this right here, that you need to look at your data to figure out the appropriate center and spread. And I'll have you look at my data, and what do you think the appropriate center and spread are? It's either going to be mean and standard deviation or median and IQR. My data is mean and standard deviation. Why? My data is mostly symmetric, and it's a little flat, a little bit uniform, but there's not extreme outliers and not extreme skew. Due to this, don't write everything, don't write what I say, but because there's not extreme skew, because there's not extreme outliers, then we would go with the mean and standard deviation here and only interpret those values. Now, I did do the extra work for you because I don't know which one you're going to have to do, but, and I would also screenshot this and put this in your output. So we want to take a screenshot of this NAS per table right here. And go right here. And we will drop this into our Word document too. I would not leave that drawing over top of it. So, but there we go with our nice output right here. So there's our analytics. And then I would say, the mean represents the average day, which is, Mary, you're only interpreting mean standard deviation, not mean standard deviation, IQR, median. And if your data is skewed or has outliers, you want to go with median and IQR. I'm going to do all 4 of these right now. I'm just telling you how it would work on interpretations, but you're not supposed to do all 4. I'm just doing interpretations to show. The mean of my data is 68.72, which tells us the average temperature in Fahrenheit. The standard deviation of my data is 0.53, which means a typical difference from the average temperature. No, that's standard error, excuse me. The standard deviation is 12.82, which tells us the typical variation from the average temperature. Standard deviation is typical difference from the mean. The IQR represents the range of the middle 50%. I wouldn't interpret this, but I'm just doing it for us practicing. The IQR represents the range of the middle 50% of temperatures, which go from 57.4 to 80.03, which is an IQR of 22.63. The median represents the 50th percentile of temperatures, which is 69.39. Yeah. You'll also notice that the median and the mean are very close. The data is not very skewed. It's only a little bit left skewed, but that's very close to 0, which means more symmetric data. So yeah, that's what we got there. Let's go back to those instructions. Where did the instructions go? We got it. Create the interval. We've almost done that. So to create the interval, you actually get your confidence right here is the margin of error on your interval. Now make sure yours is not 90, 95, or 99. And you can go right here and go equals, and we're going to grab the mean minus the confidence level right here. And then go equals mean plus the confidence level right here. We're going to round these to 2 decimals by clicking both and deleting decimals. And then we could probably make the numbers bigger to make them easier to see. And then we could go right here and we're going to merge cells. How did I forget how to merge cells? Can I right click merge cells? How did I forget that? Oh, I forget random things. So confidence interval. 95%. 95% confidence interval. There should be merged cells. Is it under data? There's always one thing you forget how to do. It's under table, right? No. Well, someone's doing it right now. Someone's like, this is how you merge the cells. Let me see. How to merge cells in Excel. Home tab, alignment group. Okay, got it. Home tab, alignment. So it's right here. It's one of these. Merge cells. There we go. That wasn't our home tab. And then center that text. Make the text bigger. Center all this text here. Make it nice and pretty. Why is that text not centering now? There we go. And then insert, however you want to make it look. Well, that went horribly. Let's just do it ourselves. We don't want that. Go lighter. There go that. And then this. That. And then I have to redo it again. Inside border, outside border. Look at that. So however you want to make it look, you could just report it, but 95% confidence interval. What matters here is the formulas. You could just report it. The mean minus the lower, the mean plus the upper. However you want to make it look. However you want to do it. Just give the interval, but that is the values. Because if the mean is different, it's going to change what the center of the interval is. If the confidence level is different, that's going to change the margin of error. This is the margin of error. You can just, if you want, 90 or margin of error, 90%. 90% confidence. Like, you could rename that so people would know what it is. That's not that important. But that is it. It doesn't have to look as pretty as this, but it doesn't hurt. Like, I didn't get a perfect screenshot. And there's that. I'll drop this over here in the Word document. What's going to matter is our interpretations. Our interpretations. Oh, looks good right there. So what step do we have next? Right up to statistics. Okay, let's make sure. Interpreting the interval. Okay. Writing up. Oh, we've done the writing up descriptive. Let's do interpreting the confidence interval. Confidence interval conditions and interpretations. Okay. So the first part right here, create your interval, we've done. And then now name the 3 conditions one needs to do to make a confidence interval for the mean. So how do we do that? Well, the 3 conditions are random. We randomly selected our data, which we did. 10%. Our data is less than 10% of the population, which we can safely assume because this is a random sampling of days. And I believe there's a lot of days that these bikes have been sold by their kiosks. So we have a random selection of days. And then the last condition is nearly normal. Now, here's the thing, though. Even if your data is skewed, with a sample size of 500 something, your sample size is large enough, which is not the condition anymore. It's nearly normal because it's quantitative data. So the condition is nearly normal. And since we're dealing with a very large sample, then it's probably going to be nearly normal. It's such a large sample size, the distribution of means for the sample size. So I would say you're probably good. You're probably good. That the distributions of means of sample size 500 and something are going to be nearly normal. Mine passes because it's already nearly normal to begin with. And then even if it's got a little bit of weirdness, it's going to be nearly normal when we have a sample size of this size. Comment on whether you pass, regardless of the outcome. Assume that all your conditions have been met. Continue and complete the analysis. Interpret for the interval for your reader. So this is where we do our 4-part interpretation right here. With the I am blank % confident that the true blank is contained in the interval blank to blank. And you would say, I am 90% confident, I think is what we are. I am 95% confident. Oh, got to make sure you do the right percent, whatever percent we did. I am 95% confident. We'll pretend it's 95. I am 95% confident. Make sure to put in your percent confident that the true mean temperature for these bike kiosks, because now we're not doing the true proportion anymore, we're doing the true mean. I am 95% confident the true mean temperature for the bike kiosk is contained in the interval 67.85 to 69.60. That is task 3. That is task 3. We have already done. We might call it here for today, but that is the start of the project, and we'll probably be able to do. Might have to do the rest on Wednesday, but I'm gonna tell people we've got the project started right here. Jump into it, get the first parts done. Maybe I could return later because I've got some. When is my next? I do have a break. Maybe come back and do the remaining project. With that, we'll be back later. Maybe. Bye for now, everyone. Bye.